Hello and welcome to another one of these ADD videos. Today we're going to be looking at Lagrange multipliers. Lagrange multipliers method is used to optimize, in other words, find extreme values, maxes or mins, however you want to put it, of multivariable equations with constraints. Okay, that was quite a mouthful. Which one of these is the constraint and which one of these is the actual function? Well, anything that's equal to a number is the constraint, and usually you will just say g of xy in this case would equal xy minus 4, and then this would be your main function you're trying to optimize. And when you're doing these problems, there's two basic approaches you can use. One is better for a single constraint. Method 2 is better for multiple constraints. So let's look at method 1. Method 1 is quick and simple, to the point. You just take all the first order partials, fx, fy, gx, gy, set these two relationships up. Fx is equal to lambda times gx, fy is equal to lambda times gy. Solve for lambda in both. Set lambda equal to lambda. Hopefully lambda equals itself. It's not having an identity crisis or anything like that. Establish a relationship between the x's and the y's. Plug into the constraint. Again, the constraint's one that's equal to the number, your g of x. And then once you got your equation all in terms of one variable, your constraint all in terms of one variable, solve for the value and then solve for the other value that corresponds to that value you just found, and then you plug into your original function. This is the f of x, whatever, y, if it's got z as well, to determine maximum. Okay, and then if we're doing method 2, again this is better for two constraints. We set up this function here in which we have f of xy plus some arbitrary variable mu times the constraint. Sorry, I forgot to label my constraint as a g there. Should be a g squeeze in, and we'll put an h there. That one looks sloppy. The other one will pass, so let's rewrite this one. Mu times g. And the g and the h are the two constraints. They should be equal to numbers. And we're going to find all partials, including the mu sub, or f sub mu and f sub lambda, which would end up just giving you the constraints equal to 0. Then we're going to set each one equal to 0, solve the system of equations. This is going to be a lot of tedious algebra. You need to be patient, but basically you're going to be setting lambda equal to lambda and mu equal to mu for the different system or different equations that have come about. Then you're going to get a bunch of critical points, and you're going to again plug into your original equation, the f of xy, the little f, not the big one that you plugged in, but the little f, to determine which one's a max or a min. Okay, so that's Lagrange multipliers concept in a nutshell. Make sure you check out the example videos. I'm going to do one for both methods, multiple constraints and single constraints. Actually, I'll probably do 2 for single constraints, one with 2 variables, one with 3 variables, and then one with multiple constraints. Okay, so make sure you check out those example videos, and as always, practice, practice, practice. Thank you and have a nice day.